Hi, I'm Chris with Sanderson Test Prep, and welcome to Section 4. So, this is the calculator section, and a lot of test takers get excited when they get to the calculator section because a lot of times it's easy for us to get used to relying on that calculator. But surprisingly, a lot of test takers actually say that Section 4 seems a little bit more difficult, and because they know you have that calculator as a tool, sometimes the calculations involved are going to be more complex because they know you have this extra tool available to you to answer the questions. So we're going to dive in, but a couple things are going to be similar to what we see in a non-calculator section, which is the questions are going to go easy to hard. So we're going to start out in the multiple choice, and we're going to cover these first few questions here. Let's start by taking a look at question 1. John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So basically, we're looking for something that is going up and then going down. So strictly, only increasing and decreasing. There's no plateau, there's no leveling off. So let's see what options they give us here. Let's see, between 0 and 30. Okay, so if we look between 0 and 30 here, well, it looks like we increase, but then we plateau between 10 and 30 there. So that's not going to be it. We can eliminate A. All right, between 40 and 60. Well, let's check. So here, we're increasing. And then between 50 and 60 minutes, we're decreasing. We have no plateau or leveling off in between. So yep, that checks out. That looks quite a bit like what we were expecting to find here. And that is, in fact, our correct answer to this question. So we can go ahead and pick B and confidently move on to number 2 without having to investigate answer choices C and D. There can only be one correct answer, and once we find it, we can select it and move on. So let's take a look at number 2. And this one says, if y equals kx, where k is a constant, and y equals 24 when x is 6, what is the value of y when x equals 5? So I'm going to write really big up here twice. So when you see these proportionality questions, oftentimes they're going to give you an equation that allows you to establish some proportionality between the variables in question. And you're basically going to take that same equation, you're going to have to work with it twice. So we're going to have y equals kx, and I'm just going to go ahead and write it twice right off the bat. And let me show you why we're going to have to do this twice. So initially they're going to give you 2 values, but you're going to have to find the missing value. They tell us that y is 24 when x is 6. So if we plug in a 24 for y, and then a 6 for x, we have to then solve for k. And k, remember, it's a constant. So once we know k, it's going to be the same in both of these equations. So if we divide both sides by 6, we get k equals 4. So we're going to take that, and we're going to plug it in when we rerun this same equation a second time. So now they're asking for y, and the value they give us, they tell us x is 5, but we know k because we already solved for k over here. So we're going to solve for y by saying y equals 4 times 5 for x, the way they gave it to us, and that will give us y equals 20. And that's our correct answer for number 2. So if you're ever unsure on those proportionality questions, just make sure that you set up that same equation twice. Do it once, find that proportionality constant, and then do it a second time to find whichever variable in question is the one that they're looking for. Alright, let's move over here to question 3. And I'm going to take a look at some geometry principles here, but then we're also going to look at this strategically. So in the figure above, lines L and M are parallel and lines S and T are parallel. If the measure of angle 1 is 35, what is the measure of angle 2? So sometimes you might come across a figure that's not drawn to scale, but they'll tell you if it's not drawn to scale. But you can always, for figures, still use qualitative relationships between values. And if we look at any sort of parallel line cut by a transversal, which means one of these lines that cuts across our parallel lines. So if these two are parallel, then the transversal would be like line T here that cuts across it. So whenever you see this scenario, if you've got a couple parallel lines cut by a transversal, just remember that along that transversal, all your acute and all your obtuse angles will be correspondingly equal. So your acute angles will be equal to each other. If this is 35 degrees, that means this is also 35 degrees here, and this is 35 degrees here, and this is 35 degrees here. And then to find these missing angles, any two angles along a straight line, so these adjacent angles, if we look, and my drawing's not perfect, but two adjacent angles make up about half of a circle, right? If we were to extend it out. So those two angles have to sum to 180. And if you do 180 minus 35, that gives you 145. So we know that 145 would be this angle in here, and this angle over here, and this angle over here, and this angle over here. So that's helpful for figuring out all those angles along line T. But we're being asked about angle 2 over here that's along line S. So what piece of information allows us to transfer some of this data over to this other line? Well, they do tell us that S and T are parallel. And if those two are parallel, then each of these acute and obtuse angles will correspond to the same values that we have along transversal T, meaning that this obtuse angle here will be 145 and this acute angle here will be 35, just like we had originally found using angle 1 at the top of, or above line L at the top of transversal T. And we can translate all those acute angles and all those obtuse angles. And as long as you know how to do this as a skill, then you can find all the values that you need. And you don't have to worry too much about it. And if you know it, it's great, but don't worry too much about the naming. A lot of times I see test takers get a little bit caught up into which one is the corresponding angle, or the alternate interior angle, or the vertical angle, or the same side exterior angles. And it's great if you know some of that terminology, but if you don't worry about it. You just want to make sure you know how to transfer all those angles around so that you can identify the correct answer, which in this case, angle 2, we found to be 145 degrees, which is answer choice D. But now I'm going to reset this, and we're going to look at this a little bit differently. So let's back it up a tiny bit. I'm going to clear out a lot of this busyness in here so it's a little bit easier to see fresh. And let's look at this question a little bit more qualitatively. I'm being asked for angle 2. If you had to eyeball that and decide if that's going to be more or less than 90 degrees, so if that's 90 right there, we might look at this and eyeball it and say, you know what, I think this one should be a little bit larger than 90. Let me take a sneak peek at my answer choices and see if I can eliminate anything. And sure enough, if I look at my answer choices, A, B, and C would all be smaller acute angles, less than 90. Answer choice D of 145, that's the only one that is greater than 90. So even if I wasn't sure of the exact geometry principles at work here, I can still maybe come up with a pretty solid guess on this question. And keeping in mind that it's question 3 out of 30 multiple choice questions in this section, lets me know that, hey, this one's supposed to be pretty manageable. It's not supposed to be very hard yet this early in the section. So if I come up with a pretty logical guess relatively quickly, I'm okay putting that down and feeling comfortable with it because we still are in the easy part of this section towards the beginning. Alright, now let's take a look at number 4. If 16 plus 4x is 10 more than 14, what is the value of 8x? Here they're asking us to write out an equation, and we have a couple key words or phrases in here that we want to just make sure that we know how to translate into mathematical symbols and operations. So here 16 plus 4x is. Whenever we see is, we want to think equals. So this is going to be 16 plus 4x equals. And then 10 more than 14 means that you have 14 and it's 10 more than that, which means we're going to be adding. So it would be 14 plus 10. And from here we can solve, so we can start to combine like terms. 14 plus 10 is 24. We can subtract 16. So 4x would then equal 8. And we could divide by 4 and get x equals 2. And then pick A, right? So hopefully you caught that. No, it's not going to be A. So be very careful. This is a very common thing that you'll see happen. Whenever they ask for some manipulation of a variable, it's very common to have an answer choice that's the value of the variable itself. In this case, we got x equals 2, and a lot of times people see 2 as an answer choice and just circle it without thinking and without being careful as to what the question is asking. The question is asking for the value of 8x. So once we find x, we have to then plug that in and solve. This would be 8 times 2. Our actual answer here is 16. So just be really careful in those situations, because it's very common for us to set it up correctly, do all the work correctly, get the right answer for x, but then miss the question because we're not being careful about reading what the question itself is actually asking. And it sounds easier said than done, but on a timed test of importance, a lot of times we forget to pay attention to those little details that can really be transformative in terms of increasing our score. So that's the first 4 questions of this multiple choice portion of the calculator section in the math, and we're going to continue with the rest of our multiple choice.